Hi everyone, and welcome to FameLab 2021. Before we kick off, I'd like to say a big word of thanks and acknowledgement to the organizations and people who have made today possible. The three partners behind FameLab are the British Council, SASTA, and Jive Media. Now, SASTA is, of course, the South African Agency for Science and Technology Advancement, a business unit of the National Research Foundation. They're all about creating greater engagement, awareness, and appreciation of science, technology, and innovation in South Africa. Jive Media works with awesome African researchers and professionals, much like the contestants today here are going to be one day, to translate their work into engaging and really wonderful media. So thank you to those three partners for making today possible, and thank you to the rock stars who are the lifeblood of this competition, and that's the partner institutions. Now this year we've partnered with 25 institutions, which are tertiary institutions, research units, and they have supported this competition, and they've also run their own local versions of the competition that have led to today's final. So it's an exciting time to be here. My name is Verashni Pillay. I am your MC for today. Now, before I hand over to Jive Media's Rabe to hear a bit about this competition, a few words from me. I am a journalist. I have worked in South Africa for over a decade as an editor and journalist. And the way that information is spreading in today's society is just remarkable. We're obviously coming off the back of a once-in-a-generation pandemic, and something very interesting happened at the height of the pandemic within South African journalism circles that I watched unfold. A group of scientists, as they call themselves, put themselves forward, and they were very media savvy. They were called Panda Actuaries. They put out a survey or a research paper questioning the efficiency or the effectiveness of South Africa's hard lockdown. Now, this was at a time when lockdown was at its hardest. We weren't allowed to leave our homes. There was a huge potential for people to disobey what was being put in place, which turned out to be life-saving mechanisms. We didn't know enough, and we were very sensitive to new information. So what happened? Immediately, mainstream media publications latched onto this research that had been put out, but they didn't report it as a private group of researchers putting out this research. They said South African actuaries. They made it sound like an official body of work. And soon headlines in mainstream publications were going out saying actuaries are warning President Cyril Ramaphosa of major effects if this lockdown goes ahead. The founder of this group said that the total deaths of COVID would be about 10,000. We now know that it has been over 80,000 in South Africa, and that's excluding access deaths. What happened after that was that the South African Actuarial Society came out and put out a statement saying, this is not our view. This is not South African actuaries. This is not an official view. But their rebuttal didn't get anywhere near the significance and reportage and coverage that the original study got. In fact, it got carried in so many mainstream publications that till today, they have huge SEO advantage because they had the first advantage. They communicated really well. They were really savvy in getting their message out there. And later on, this group strayed into anti-vaxxer territory, casting doubt on taking vaccines, putting forward dubious solutions like ivermectin. And so what happened was that the real information got lost because the people who were spreading out information that was not as accurate were far more media savvy. Until today, because of the way analytics works and SEO and the web, those voices are still louder. You will struggle to hear what the South African Actuarial Society, the real scientists, have to say about lockdown. Instead, you'll hear what a private group with dubious information has to say. And that's why, for me as a journalist and for us as the public, the work that you guys are doing, you contestants that are about to take part in this competition, is so important. We need you more than ever. A recent study in South Africa found that, and they surveyed around 1,000 people in South Africa and Kenya, and they found that about 43% of them get their news from social media. This is at a time when trust in mainstream news sources, like ones that I would typically work for, are at an all-time low, so people would prefer to get their news from social media. But the study also found that many of those people suspected that the information they were getting was incorrect or could be incorrect, but, and here's the crucial thing, they shared it anyway. It's a scary time to be living in, and that's why we need scientists like yourself doing really clear science communication. Now, that's it from me. I'm going to hand over to Robert Ingalls, who is, of course, the co-founder of Jive Media and its director. And Robert's going to tell you why it's not just good for us as the public and journalists, for scientists to communicate, and a big chore for the scientists. It's really good for you as a scientist as well. So over to Robert for a few words before we kick off the competition.
Thanks very much, Verashni, and welcome to everyone. Greetings to all of you, and of course, huge congratulations for getting this far along the competition. It's really wonderful to be with you today. When we talk to researchers and ask them what are the things that prevent them from getting involved in public engagement, science communication, and public conversations about science, some of the most cited ideas are incentives and skills. So incentives on the one hand is this idea that there's a lot of pressure on scientists to be publishing, to be writing in South African academic institutions, to be teaching. And so they don't really have enough time to get involved. And there are no strong incentive systems at the moment for getting researchers involved in public communication. And I think that's that assumption needs to be challenged a little bit. So I just looked at a little bit of research. There are three little demonstrations that perhaps those incentives are there. They're just not quite as obvious as they perhaps should be. And the first one is a British Medical Journal study of about 25 clinical trials, which looked at public participation and involvement in those clinical trials, and found that public participation in and engagement in those increased the enrollment and participation in those trials. And then secondly, despite those assumptions that perhaps taking time out to do public engagement might take away from time that you might otherwise spend on writing and publishing, in fact, the publicly visible scientists are generally, and this was the result of a number of different studies, are generally producing more work, and they're producing higher profile and higher impact work. And then finally, this opportunity that's being created by incredible advances in media and how media works, or changes, let's call it. We're not always sure if they're positive or negative, is allowing huge numbers of people who might previously have been excluded from research, marginalized groups, key populations, to participate in research. And so in all of these ways, while there may not be, and while institutions may not have figured out how to do, for instance, numerical or promotional recognition of public engagement, it's certainly clear that it's making scientists into better scientists, more able to have positive impact in the world. So the second thing really is then about skills. If we've convinced you that public engagement is an important part of doing research, then people say we don't have the skills, we don't have the confidence. And when we saw the FameLab project in the UK in 2010, we realized that it was a really powerful vehicle that could be utilized to develop skills and grow skills. And so we were really thrilled to be able to have offered this competition as an initiative over the last 8 years through incredibly powerful partnership through the British Council and through SASTA. So the British Council held for many years the international license to run the competition. And during that time, it's grown from just one country in the UK to over 30 countries that have run the competition around the world. And the South African Agency for Science and Technology Advancement, SASTA, which is a business unit of the National Research Foundation, has really created an environment in which we can host and offer the opportunity for institutions around the country to host elements of this competition. And as Verashni mentioned, this year we've had 25 partners of this competition, and many of the people among these finalists are representing some of those partners today. So just in closing, and perhaps a message to the participants themselves, I'm quoting Charles Dickens. He said, "It was the best of times, it was the worst of times, it was the age of wisdom and the age of foolishness." And in fact, he was talking about a period in 1859, just before the French Revolution. It was a time where for some incredible things were happening, and for others, they were sitting in the most difficult of circumstances. And I think that the revolution that we're seeing now in terms of communications technologies and the way that science is changing is really fundamentally changing. And Verashni's spoken about the huge power of media and how it can be used in positive ways and negative ways, and possibly with unintended consequences sometimes. So really the message now is that the barriers to communication are coming down. You have at your disposal incredibly powerful tools for reaching huge audiences out around the world. But it's really in conversation and in dialogue that your science can start to have powerful impacts in the world. And so this is really just an encouragement to keep on having the creative and courageous conversations that are necessary to make your science have positive impact out in the world. So congratulations once again for being here. We're looking forward to watching you on your journey of research communication, and we're looking forward to watching you as you create the world that we're all looking forward to. Thanks, Verashni.
Thank you, Robert, for those encouraging words. I hope that those who are watching today as scientists are encouraged and motivated by what Robert had to say to get out there and make your research and your science more accessible for a larger audience. Now we're going to hear from Michael Ellis, who is the manager in the Science Communications Division at SASTA, for a few words. Over to you, Michael.
Good day and welcome to all of you. It is such a privilege to welcome you all to FameLab South Africa Finals 2021. At the National Research Foundation, our vision is research for a better society. So we view the broader South African society and local communities as being integral to the research process. This requires effective and relevant communication between scientists and the broader society. The National Department of Science and Innovation have also set priorities which highlight the importance of developing science communication for enhanced engagement. And the key aim for FameLab is to develop the skills and confidence of young scientists or early career researchers to enable them to share their work more broadly outside of their immediate peers and scientific communities. As a business unit of the National Research Foundation, we at the South African Agency for Science and Technology Advancement value such programs as FameLab, which have made and continue to make a valuable contribution to science communication skills development for young scientists in South Africa. Through the workshops and masterclasses, as well as the opportunity to develop skills and gain confidence in presenting scientific research in an engaging and a captivating manner. With the challenges of the global pandemic, we are also pleased that by working closely with our partners, Jive Media and the British Council, we have been able to deliver successful virtual heats and semi-finals for FameLab 2021. I would especially like to thank the British Council for their wholehearted support and commitment to this project over many years, and we look forward to working with you on other projects into the future. We would also like to acknowledge our HEAT partners, the higher education institutions, science councils, and centers of excellence, and other research organizations who have supported the FameLab competition and their young researchers through hosting workshops and heats in their institutions. Without your support, we wouldn't have these brilliant finalists here in today's session. So after 14 grueling heats across the country and over 300 young researchers who have stepped up and made their voices heard, now is a time for us to engage our minds and prepare ourselves for some captivating visual imagery of some of the scientific research that is taking place in South Africa. So I would like to end off by wishing you well, FameLab finalists. We look forward to hearing you profile your research and the journey that you've taken with that research, as well as the impact that your research is having in South Africa. Good luck, and know that we are rooting for you. Enjoy the day. Cheers.
Now, onto our esteemed panel of judges who will be making the unenviable decision of choosing a winner from today's contestants. First up, we have Professor Nox Makunga, or Nox as she is known. Now, Nox is a fascinating scientist. She is botanist who works at the Stellenbosch University at the Department of Botany and Zoology. And I love that Nox has a real interest in working with different kinds of knowledge systems and making sure that they work together and not just in mainstream academia. She's even founded an organization that promotes Black botanists globally, whether they be formally or informally trained. And her work is multidirectional. It combines the areas of biotechnology, ethnopharmacology, and phytochemistry. I hope I said that right. Now, she's won many awards. I won't mention them all, but one of the recent ones is, of course, the prestigious Fulbright Fellowship, which she was at the University of Minnesota in 2017 to 2018. So, Nox, we are so glad to have you here as a judge today. And I want to just ask you, what are you looking for in the contestants today as you're going to be making your evaluation of their talks?
I am looking for dynamic and exciting engagement that's actually easily accessible to non-scientists and the general public. I'm also really looking for that magical something which some people call the X factor. So that's what I'll be looking for in our contestants today.
Well, I think that you certainly demonstrated for them, and I hope that we see lots of that from the contestants. Our next judge is Sibusiso Biyela. Now, Sibusiso is a science communicator at Science Link, and he works with scientists to do what this competition is all about, to help them to make their work more accessible and to get it out there for different audiences. Now, Sibusiso has a keen interest in the decolonization of science, which I'm sure is something we're all passionate about. And he's also interested in translating various scientific terms into South African indigenous languages using science communication principles, which is absolutely fascinating. Sibusiso, so good to have you here. Now I have to ask you, you work with scientists to communicate their work. What is your pet peeve when it comes to how scientists communicate their work to the public?
Thank you very much for the introduction. My pet peeve when it comes to scientists that I listen to and talk to is them not giving audiences the benefit of the doubt, trying to dumb down facts too much when it's just they have to clarify it. And I think it's important for scientists to communicate the process of science and explain how they found certain results, in addition to explaining why they matter.
Well, that's actually quite important. I would have thought they should dumb down a lot more, but that's important to know. You're right. We all do have some sort of knowledge and interest, and it's good to talk to us as equals. Thanks, Sibusiso. Next up on our panel of judges is Natasha Joseph. I'm a big fan of hers. I've worked with her through the years. She is a really respected journalist and editor in the South African landscape and regionally. She has over 15 years of experience in South African newsrooms from the Atlantic, and she's written in the Atlantic, the Big Issue South Africa Index, and as an editor, she's worked in City Press and The Conversation Africa. And at The Conversation Africa is where Natasha has really worked hard to translate complex research and researchers' work into accessible, engaging news articles. And as someone who has worked with Natasha, I can say that she does that really, really well. So, Natasha, my question for you, what is the most common error you come across or mistake when trying to edit an expert's writing to make it more accessible for a general audience?
Thanks, Verashni. It's great to be here. I think one of the things that I notice with a lot of scientists when they're trying to write for ordinary folks is that they strip away all of the sense of wonder that they bring to the work that they do. I think all of you here will have got into science because you're fascinated and you're passionate. And I think it's quite lovely to let your nerd flag fly and remind people why it is that this stuff is fascinating and important and cool.
Well, that says it all. It makes me want to be a scientist. Our final judge is Tshiamo Legoale, and Tshiamo is a former FameLab alumni. It's so exciting to have her join us several years after she won in 2017 to help choose her, one of her successors, the next FameLab winner. Now, what does Tshiamo do? She has spent a decade in the mining sector where she focused on small-scale mining communities and technology development and transfer to marginalized and disadvantaged mining communities rather. She's currently the social manager for the Trans-Caledon Tunnel Authority, which is a large water infrastructure project implementer for the Department of Water Affairs and Sanitation. innovation. She helps with social impact and stakeholder management of the company's projects. Now, she's passionate about STEM sector and especially how it can be a tool to improve the lives of ordinary people. Tshiamo, we're so glad to have you here joining us as a judge today. As a former FameLab winner, why do you think science communication is such an important skill, especially for young scientists?
Having me, Verashni. And I think to answer your question, science takes on so many facets. When you're in the lab, it's a hypothesis. When you're reporting in conferences, it's scientific findings. When you're talking to politicians, it's advice. When you're talking to the ordinary persons, it's empowerment. And so I think it's very important as a scientist that you're able to translate your science into every language for every audience to understand, and so that they are better equipped to make decisions.
Well, that's a great answer, and I'm sure you're going to be watching carefully for that to come across in contestants today as they deliver their talks. So with that, it's time to launch the competition. I'm sure nerves are high amongst our contestants, but don't be nervous. You guys have prepped. You've got this. First up, our first contestant. Her name is Hima Rama. She's all about fish. This girl loves the underwater world. She is an aquatic ecologist from the University of the Witwatersrand, and she's passionate about conserving the watery home of our scaled friends. Her research about the fish of Lake Malawi will help to protect the incredible diversity of this lake, to sustain communities and fascinate us for years to come. And she believes that the only way to protect our natural resources is to instill a passion for it in the public. We're looking forward to hearing from her. Over to Hima for her first presentation of the day.
Let's break ourselves out of these plastic boxes and settle in a little village on the shore of Great Lake Malawi. It's bright and early. You push your little wooden canoe out into the ocean of fresh water that stretches as far as the eye can see. Looking over the edge, you see thousands of fish, water thriving with life. Every day, you set out to cast your nets so that you can quite literally on the table. But what if one day you look over and there's nothing left to see? What if one day you pull up your nets and there's nothing left to catch? What if the fish of Lake Malawi disappeared? Good morning, everyone. I'm a scientist studying the fish populations of Lake Malawi. Lake Malawi is a critical resource shared by not one, not two, but 3 African countries, and supports the livelihoods of more than 1.6 million people. Did you know that Lake Malawi has the largest number of freshwater fish species in the world? The lake is home to thousands of fish species, many of which can only be found within the lake itself. People come from all over the world just to see them and even take them home to keep in their tanks. But through pollution, overfishing, and habitat destruction, these populations are being threatened. 10% of species in Lake Malawi are at risk of extinction. While this may not sound like much, let me illustrate. If each one of these represent a fish species in Lake Malawi, this is how much we stand to lose. Since these fish are so valuable, we know we need to protect them. But how can we do this if we don't know how their populations are changing? We can only do this by monitoring the situation. So I invited the fish to dinner. By placing underwater cameras with little baited snack stations in different parts of the lake, I was able to record the fish that came to the party. This allowed me to have a look at all the different groups of fish living in the lake without stomping through their homes like the big friendly giant. Using this footage, I could count the individuals of different populations and see how their numbers are changing over time. I could also see where each species was spending its time and where they like to live. This information helps us to identify which species need the most help and protect the areas that are most important to them so that we can allow their populations to recover. It helps us to create plans to use the lake sustainably so that these fish can be around for years to come, and the people who rely on them never have to worry about where to find their next meal. Thank you.
A huge thank you to Hima for that fascinating talk. As someone who has gone swimming and snorkeling Lake Malawi, I would hate to be there with no fish. So we're so thankful for the work you're doing. Now, over to the judges who are going to give their feedback and perhaps ask a question or two. We have Sibusiso and Natasha who are going to be going one after the other. Over to you, Sibusiso, and then to Natasha.
Thank you so much for that beautiful presentation. You really put us in that vision of that scenario of losing all the fish one day, and that's a scary situation. So what I would like to ask you is, in the work that you've done, are you talking to the communities that depend on these fishes? Or if you have plans to do so, how would you as a researcher engage with them to help them participate or take part in the research?
So this was running for a long time. I'm not the only researcher who's working on it. And because of COVID restrictions, I haven't had the chance to interact with the community. But there are other people who are doing it because it directly informs the policy that governs the way they use the lake. And it's very important that they have their input because they are the ones who have the most impact on the lake. So I think it will be a valuable thing to do in the future, but as of right now, we're not doing it because of COVID restrictions.
That was lovely. I really enjoyed that. And I thought that you used your props really nicely. I wanted to know, how did you choose where to put your cameras? I mean, it's such a massive expanse of water. So how do you as a scientist figure out where's the best place to invite all your fish to dinner?
So how we did it was we chose a specific place where we know that a lot of people are using the lake. It's actually on the Mozambican side of the lake. And what we did is we tried to randomize it. So we used a couple meters as an indication to randomize where we deployed the cameras. And then we also tried when we went out, so it was a couple days of sampling. So when you go out again, you see what you have, and then you try and pinpoint places where there's different types of habitat, because we want to include everything that's available to the fish.
Great, thanks very much.
Thank you to our judges for those fantastic questions, and thank you again, Hima. On to our next contestant, and that is Lungile Buthelezi. Now, at a young age, she's become a full-time lecturer of optometry at UKZN, the University of KwaZulu-Natal, after completing her master's in optometry. Her research brings together optometry, healthcare, and HIV, such a critical issue in our society, because she looks at a phenomenon called HIV ocular pathology. She also shares her experience and passion with the community by promoting primary eye care and HIV education in KwaZulu-Natal. So Lungile, over to you for your talk.
Hi, I'm Lungile Buthelezi, and at the moment you are looking at me through the eyes of an HIV-infected person who is losing an aspect of their vision. So how does this come about, you may ask? Well, let's get into it. HIV-positive people take ARVs, which help them live healthy and longer lives. It was an amazing discovery for us. However, this medication has found to be slightly toxic to how our bodies function by changing or affecting how something called mitochondria functions. Now, mitochondria are found in our cells and they work like little batteries. When these little batteries are fully charged up, they help our bodies function well and we live healthy. However, when they are dying out, they may affect how some of our organs, including our eyes, work. So why does it matter how our eyes work? Well, it's how you navigate 90% of your world, how you do your work, appreciating the face of a loved one. Now imagine losing this ability because you have HIV. This is the dilemma that some of these people are faced with. Now, did you know that your eyes talk? Yes. Last month, your eyes told me that you are not taking your diabetic medication properly. They also told me that you may have a brain tumor. And they also told me that you are way too stressed, spending way too much time in front of the computer and drinking too much caffeine. You need to relax. Yes, I can get an overall view of your health just by looking inside your eyes. This is because the blood vessels and nerve tissue in there are directly visible. This is how we're actually able to get early diagnosis on certain diseases. Now, I've told you all of that just so I can say, I plan on checking how ARVs and HIV are affecting your body by looking inside your eyes. It is as simple as taking a picture. Selfie time! No, I'm not going to take a selfie, but I am going to take a picture of the inside of your eye, more specifically the retina, the part of your eye that helps you see, using something called optical coherence tomography, or OCT for short. Here's how it works. When we look directly inside your eyes, your retina may look like a flat surface, like looking at the top of a cake. What OCT does is slices up the cake and shows us the inside layers. Now, we already know that HIV positive people and non-infected people do have slightly different layers. However, we aren't really sure what the problem is. And this is where my research comes in. I want to find out, is it the disease or is it the ARVs that are affecting our eyes and our body? That OCT picture will take a picture of this layer, which contains pigment that will light up whenever there's abnormal activity or mitochondrial dysfunction. It will light up a different color compared to people who are non-infected. This would be a non-invasive and convenient method for us to track how HIV and ARVs are affecting the body. Let's let the eyes do the talking. Thank you.
Well, Lungile, I would love to sit in your lecture room and hear you talk all day. That was absolutely fascinating. Thank you so much for sharing that. Over to your judges, who are Professor Makunga and Tshiamo. Professor Makunga, you first, and then Tshiamo to ask your questions.
Thank you so much, Lungile. That was really lovely. And it's a very important topic that you're actually covering there. I wanted to know, how do you choose the people that actually participate in your research? Where are the patients actually coming from?
Okay, so I will be getting them from a tertiary hospital in Pietermaritzburg. All of the patients that I'll be getting. So there's 3 groups, basically. One group will be HIV positive on ARVs. One will be HIV positive not taking ARVs, and a control group that is not infected. So they're all coming from the hospital, patients of the hospital.
Thank you so much.
Hi, Lungile.
Hi.
Thank you very much for the presentation. I'm not sure if it's by design that your judges have eyesight problems or not, but
it's fate.
Just a quick question. The OCT technology that you plan to use, what type of light does it use? Is it UV? Is it X-ray? And could it have some adverse reactions to the eye itself?
Yes, so it is UV light, and it's of a certain wavelength, so just above 600. And that's how the pigment in that layer excites. And it has been, the research has been done to see if there are adverse effects, and there are none. So anybody epileptic, anybody can take the picture. It's not non-risky.
All right, thank you so much.
Thank you.
Thanks again, Lungile, for the important work that you're doing. I think it's so fascinating. You know, we've been living with HIV in our communities for so long, and we still have so much more to discover. So thank you for that. Our next contestant is Letago Kgomoeswana. She is an MSc candidate at the Northwest University. And Letago really is about, as she puts it, science for the people, with the people. Her current research is about the impact of climate change on agriculture, specifically in the Limpopo province. Now, a large part of her work involves hearing from local farmers about how they adapt to climate change. This is taking the issue of climate change outside of big boardrooms and global gatherings, and to the people who it's affecting the most. She believes that everyday people have a significant contribution to make to scientific research, and we couldn't agree more. Letago, I can't wait to hear your presentation. Over to you.
My favorite place in the whole wide world is at 24 degrees, 18 minutes, 49 seconds south, and 29 degrees, 39 minutes, 56 seconds east. You're probably wondering what the location of this is. My grandfather's farm, located northeast of the Limpopo province in a beautiful town called Tzaneen in the Mopani district. Now, Mopani is a tropical paradise and one of the province's agricultural hubs. Because it is a tropical region, it is highly susceptible to climate change because it only has 2 seasons, the wet and dry seasons. Now, climate change is long-term variability in weather patterns, often characterized by increased temperatures and changes in precipitation, often resulting in high rainfall in one region and low rainfall in another. A key risk associated with climate change is the risk of natural hazards or disasters. Now, in my region, in the wet season, we have increased floods, thunderstorms, and hailstorms, while in the dry season, we have increased dry spells, droughts, and veld fires. The impact of these hazards can be seen on agriculture through decreased crop production, land degradation, animal disease, and poor crop health. As a geographer, I have the wonderful opportunity of studying both the natural and social sciences. Key to the social aspect of my research is public perception and understanding of climate change. I believe that how well farmers perceive and understand climate change determine how well they adapt to it. Now, climate change is not a new phenomenon, and therefore adaptation to it cannot be a new concept. In the Mopani district, farmers use more indigenous knowledge methods as opposed to those prescribed by the Department of Agriculture. Now, have you ever thought of combining firewood ash and chili powder to kill weeds instead of commercial herbicides? Or tried to increase the soil fertility and water retention on your farm by composting crow manure made from the excrement and urine of animals and chicken manure? These are just two out of a wide range of methods used by crop, livestock, and mixed farmers in my region to adapt to climate changes. I believe that science is for the people, with the people, and that scientific research should benefit everyone who lives, works, and knows the land, which is why my research advocates for the inclusion of indigenous knowledge systems as a viable source of knowledge for disaster risk management strategies in climate change research, not only in the Limpopo province, but in the country as a whole. Thank you.
Letago, who knew that chili powder could be used as an alternative herbicide? I'll definitely be trying that out in my veggie garden. It's such a thrill to have someone like you working with vulnerable farmers and communities in Limpopo. So thank you for the work that you do. Back to the judges, who are Sibusiso and Natasha, who are going to take you through their questions and comments. Sibusiso, over to you first.
Thank you so much for that wonderful and informative presentation. I would like to ask you, what is something that a lot of people usually get wrong that you found in your research about indigenous knowledge systems? What is something that you think the public or the science or other scientists should know about?
Right. I think that the public that use the indigenous knowledge value it far more than scientists who rely a lot on scientific knowledge. I think that there's a lot of value to be found in indigenous knowledge, or it wouldn't be indigenous knowledge. You know, the fact that it is being passed down means that it works. You know, and I think that's something that we need to look into as scientists, that we can use the two together. I'm not saying that one should be greater than the other, but I do believe that bringing the two together is very helpful, because a lot of the people who use the indigenous knowledge benefit from it.
Letago, I need to tell you that I grinned at you from the moment that you started speaking right the way through to the end. I know it's difficult to tell when cameras are off, but I love your energy, and I think your research is fascinating. Sibusiso stole my question, but what I wanted to know is, when you're dealing with people, there can be challenges that you face in kind of approaching people as a scientist, often out of the blue, even if it's an area that you're familiar with, in a language that you speak. So what would you say the biggest challenge has been for you in conducting your research so far?
For me, I think it was dealing with the more elderly of the farmers, because I need to explain my research to them first, I guess, which is where science communication came in, because I had to sit down with them and explain my research to them in a language that they understood. So my area is predominantly Pedi and Xitsonga speaking. And so all of these things that I'm saying in English, I need to now say in Sepedi in such a way that it does not take away from the key of what my research is. And I'm still able to get response from them. So I had to do a lot of translating, a lot of sitting with family as well. My research was my entire family. They helped with questionnaires and just with approach. So that has been the most difficult part, to say that you can see that a lot of these farmers understand what climate change is. they cannot put it in scientific terms, but they can tell you that the rains aren't raining when they should anymore. This type of crop does not grow in this area anymore. And so just being able to bring that back into the science from a different language and from a different perspective has been quite a challenge, but it's also been very eye-opening in terms of the importance of science communication.
Wonderful. I look forward to reading more about it.
Thank you so much.
I have to concur with Tash. For a lot of you, our cameras are off so that we can just give you the spotlight, but I just am grinning from ear to ear, and I think I'm going to have a face ache at the end of this. The work that you guys are doing and your energy is just so beautiful, and Letago, that really does go for you as well, and for all of you so far. It's just been beautiful to watch your energy and to know that people are like you are in these spaces. So next up in our line of awesome young scientists is Tasvi Daya. Tasvi is a first-year PhD student at the University of Witwatersrand. She's completing her degree in the field of cancer biology. And what she's specifically looking at is the link between cholesterol and cancer cells. Now, this is obviously a huge area of research. Her curiosity drives her interests in the ever-changing pharmaceutical and medical industry. And as Tasvi puts it, she feels that it's a huge privilege to contribute to cancer research, potentially saving millions of lives. So Tasvi, over to you.
Cape, check. Mask, check. Innocent civilians, check. Humans, stop your worrying and concern. Come on over to my side. There's a truth you want to learn. I know all about the villain that's residing amongst you. Cancer, you call it? I must admit, this ongoing battle between your pancreas and this villain has to stop. I know that you're tired and bruised and on the verge of giving up, but wait. Here, take my hand. Hold on just a little longer. Cancer may have started this war, but we will finish it. Allow me to introduce myself, ladies and gentlemen. I am Captain Cyclodextrin, your superhero and a future member of the Chemotherapy Club. You can consider me a secret weapon against the cancer army. Speaking of which, those mutated cells are on the way. Quick, everyone come closer. Let me divulge my plan of action. Now, I already know the question on your mind. If I'm really a superhero, what's my superpower? Well, as Captain Cyclodextrin, I act as a natural vacuum. Okay, it's no Thor's hammer or Wonder Woman's whip, but it can save millions of lives. You see, I have a strong attraction for cholesterol. Cholesterol is a fat-like substance found within cells that protects them from death while allowing them to move, grow, and multiply. However, the cancer army has much more cholesterol within their cell membranes, and that's why they're so much stronger. Don't fear. That's where I come in. All I have to do is make contact with the cancer cell. Then I can use my vacuum to suck up its cholesterol. After I've drained them of excess cholesterol, they'll be weak. And that's when the rest of the chemotherapy club will rush in to finish them off. With this plan, the aim is to defeat. Humans, I look onto you and I see hope. I see strength. I see bravery. Have faith in me. I, Captain Cyclodextrin, will alleviate this enemy. So as I go to war, come and show me your support. Cyclodextrin, Cyclodextrin, Cyclodextrin. Thank you.
Tasvi, we might have to send that into the Marvel universe for them to consider you as one of their new superheroes. That was absolutely entertaining. Thank you so much. I love what you've been discussing, and draining cancer cells of cholesterol sounds absolutely fascinating. Over to your judges, who are Professor Makunga and Tshiamo, with their questions for you.
Tasvi, thank you so much for an incredible presentation, and we all do love a superhero indeed. That was a wonderful delivery. I was just wondering, how do you actually monitor cyclodextrin? How would you actually know how much is there and how it's working?
Okay, thank you so much for that question. So the way that I would work, experimentally at this stage is just based on concentration. So I would, use a certain concentration of this drug and see what the effect is on cell death. Obviously, we don't want the concentration to be too high because then it becomes toxic to the healthy cells. So I would just use a concentration gradient and try and find a perfect value in between high, low value that can have an effect. I hope that answers your question.
Yes, it does. Thank you so much.
Hi, Captain. How's it? I was chanting with you. So my question is a very short one. Right, so cyclodextrin will absorb the cholesterol from the cancerous cells, but then what next? How does that then exit the human body? Or does it just stay there? When do you as captain exit the crime scene?
Thank you so much for that question. That is actually something I was researching. Unfortunately, we have not yet, the mechanism of action is not yet elucidated once the cholesterol has entered the drug, because obviously it's like an enzyme ligand kind of molecule that works together. So we're not too sure what happens when the cholesterol is inside of the drug, but we do know that it doesn't stay on the cell membrane. So it could be maybe floating around the body and then it's perhaps, it exits the body, but I'm not 100% sure on that mechanism yet.
All right, thank you very much.
Thank you.
I think the hallmark of a great scientist is to say when they don't know. So thank you, Tasvi, for that presentation and for your answers to those questions. Next up, we have Oluwatoyin Onipe. Now, she is a food scientist with a background in microbiology who has transitioned to being a food scientist and who trained at the University of Venda. Who here does not love magwinya? She has studied how to make that healthier for those who consume it. Over to you.
Picture an old-fashioned roller coaster filled with ups and downs. That's what your blood sugar and insulin level looks like throughout the course of the day. The high that comes from after a meal and the lows thereafter. What you should aim for is a kiddies roller coaster filled with gentle ups and downs. As food scientists, we use a tool called glycemic index, GI for short, to measure this roller coaster event that goes on in your body. GI rates carbohydrate foods based on how they raise blood glucose level after a meal. IGI foods have a number from 70 to 100, example, white bread, donut, amagwinya, and low GI foods have a number from 55 and below, example, all grain foods, and that is what you should aim for. There is a key component, a key macromolecule that can help reduce the GI of carbohydrate foods, and that is fiber. Fiber is the edible part of a plant that is not digested in the stomach, in the small intestine, but it moves to the large intestine where the microorganisms act upon it through a process called fermentation. Short-chain fatty acids, a group of compounds, is released, and these confer health properties on the body by helping to regulate blood glucose level and as well helping to manage hunger and the feeling of fullness. World Health Organization recommends that an adult should consume 29 to 40 grams of fiber per day. Currently, South Africa is at 10 grams, which means there is a fiber gap. My research comes to bridge the fiber gap. One way in which I've done this is to take fiber from oat bran and wheat bran and introduce it into amagwinya, a deep fried dough snack that is known for its high oil and high carbohydrate content. And the result, the GI was reduced from 80 in amagwinya without wheat bran to like 56 in amagwinya with enrichment through bran, oat and wheat bran. As well, the oil content from around 20 to 60% reduction in the oil content. I am Oluwatoyin Onipe. I am your food doctor, and I'm here to bridge the fiber gap. Thank you.
Thank you so much, Oluwatoyin, about telling us about the gap in fiber. So important. Your judges are Sibusiso and Natasha. Over to you guys to give your answer, your questions and comments.
That was a wonderful talk. Thank you so much for that. You've gotten me a little hungry for Amakwinye right now. So I want to ask you, in the work that you've done, have you had taste tests? And how are people liking the Amakwinye that you've made? What's been the response?
Yes, we have had a taste test because that's what guarantees our success as food scientists, being able to produce something that is nutritious as well as acceptable to the consumers. And we did a taste test of our enriched Amakwinye, and it was fairly acceptable by the community, yes.
I'm now also craving Amakwinye, and it's left me wondering, how did you come to choose Amakwinye as the food that you are working with and adapting in your research?
Okay, we did a survey, and Amakwinye was noted in the rural community of Limpopo, where I stay. And we noticed that Amakwinye is consumed mostly by high school learners in the university students. You find it on the street corners by vendor, you find it in the university cafeteria. It's fairly everywhere, and it's heavily consumed. And we thought this is a research gap that has not been filled, and that's how we came about working on Amakwinye.
Thank you.
Thank you again, Oluwatoyin. The need for food technologists and scientists like yourself is immense to help our country lift itself out of the, obesity and everything else that we're facing. So thank you for that. Great. Our next contestant is Caitlyn Reddy. Now, Caitlyn is a passionate biologist at UCT, the University of Cape Town, and she has a special interest in paleontology, taxonomy, and macroevolution. Now, she enjoys looking for patterns in the past that can help us plan for the future. Her current research unravels the evolution of an animal, I'm not going to try to say, but it is a prehistoric creature somewhere between a giant lizard and a meerkat. Sounds positively delightful. She helps to piece together the magnificent puzzles of the past, rather, that allows modern humans to better understand our history and how the planet has changed. So, Caitlyn, I can't wait to hear what you have to say to us.
Life finds a way, an iconic quote from one of the most influential films of the 20th century, Jurassic Park. I highly doubt that director Steven Spielberg could have possibly anticipated the immense cultural impact of his work, because for myself and countless others, it was within this lush cinematic experience that we fell in love with the prehistoric world. And how could we not be awed by the 13-meter-tall Brachiosaurus, the kingly crown of the Triceratops, or the ferocious jaws of the infamous T-Rex? It was as if the prehistoric world was beckoning to me to explore it in all its majesty, and I did. Today, I'm a paleobiologist, and I'm fulfilling a lifelong dream. But to many of you, this career choice might seem quite odd. Why, as we face the unprecedented challenges of global change and social unrest, should we care at all about some long dead bones? And my answer is this. When I hold a fossil in my hands, I'm opening a window through which I can see into the past. Dawn is breaking, and the same sun that shines upon us now is rising over a very different Africa. Its heat warms the rocks, which radiometric dating informs me are 250 million years old. A gust of wind rustles through the grassland, carrying with it pollen grains, which will become fossilized in the sediment and show me what sorts of plants grew in this foreign land. As this new day begins, a small creature is emerging from the sand. It has no idea that millennia will pass and its small life will still matter, that with fascination and reverence, scientists will study its remains, analyzing every inch to piece together the unique puzzle of its existence. As it greets this new day, its young lie sleeping, nestled in the bottom of a spiral burrow where they will be frozen in time forever within a fossilized cast. From excavation to the laboratory to you here today, paleoscience allows us to share these stories. And not only that, but keeping detailed chronicles of the past enables us to better understand our modern biodiversity, model long-term changes, and better inform our decisions about our future. This little creature would eventually go extinct, following one of the greatest mass extinction events our Earth has ever seen. But its resilient relatives would live on, forging their own way through time and through space, and ultimately giving rise to every single one of us listening here today. So when I'm faced with the unpredictable future, I need only look to the past and be reminded that life does indeed find a way. Thank you.
Caitlyn, I could definitely listen to you talk for a lot longer. What a beautiful illustration of life and just creating such magic in your area of expertise. Thank you so much for that. Over to Professor Makunga and to Tshiamo for their feedback.
Absolutely agreeing there with Verashni. A wonderful modulation of the voice and brilliant storytelling. I have no idea what radiometric dating is. Can you explain this to me?
Yes, of course. So it's actually a very commonly used technique when looking at anything older than we are today. And that's when we take some kind of matter, it could be organic or inorganic, and we use the amount of isotopes that are inside that matter and their decay time. So we know how long it takes for them to decay. We can measure that, and that can give us a general idea of how old something is. So we'll test the amount of carbon or uranium in some kind of material. And because we have a benchmark for that, we know how long that piece of rock has been sitting out there in the landscape.
Thank you. I'm much more informed.
Thank you.
Hi, Caitlyn. I just want to reiterate what everybody's saying. You have a great way of using your voice and telling stories. I felt like I was one of the characters in Jurassic Park as you were talking. Just a quick question. Are there any lessons that we can learn from prehistoric animals that can help us to preserve endangered species that currently are alive?
100%. And for me, it's one of the most important aspects of paleoscience, because I think people associate paleoscience with only looking at what happened in the past. But modern animals are all evolved from animals that lived in the past, and we can trace those lineages back. And through paleoscience, we can have a look and see what those animals' lives were like. What sort of diseases did they have? And because we know about the climate change at the time as well, we can see how they responded to those changes, and we can model how modern animals may respond to similar changes in our global change, climate change, habitat destruction, etc. So definitely really important part of the work that we do.
Okay, thank you very much. That's very informative.
Thank you so much.
Thanks again, Caitlyn, and all the best in your future research endeavors. Next up, we have Kaylan Reddy. Now, you know, alternative medicine is all the rage right now, and people really want to know how indigenous societies were doing it. So scientists like Kaylan, who can actually bring us the facts on that, are really important. He is currently doing his doctoral research on the plants that Khoi and San people use as medicine to treat depression and anxiety, which is obviously in such a rise in our society today, in the West and right here. He's always loved plants, and now he wants to use his research to bring indigenous plant-based medicine onto the global market. So Kaelin, in an industry where there is so much quackery around this area, we're so excited to have someone like you give us the goods. Let's take it away.
All of us have been affected by the COVID-19 pandemic in some way or another. A major way that many of us have been affected is in terms of our mental health. However, the mental health pandemic is not a new one, especially in terms of anxiety and depression. About 264 million people worldwide suffer from diagnosed depression, and 50% of these individuals also suffer from anxiety. These people often have to take medication for prolonged periods of time in their lives and have to find medication combinations that work for them. And thus, the search for new medicine that can help these people live a more comfortable life is never ending. But where do we even start to look for this? Well, the answer lies in nature. And what if I told you that here in South Africa, we're in the perfect position to search for new medicinal plants? Firstly, South Africa holds 10% of the world's plant diversity in the single country. And secondly, we have a rich African traditional medicine system to peer into for answers. In my research, I look at a medicinal plant that was used by the Khoi and the San people, known as Sciletium or Kogut. Traditionally, the plant was used to suppress hunger and thirst on long trips. However, it also had some interesting mood-elevating activity that could be the answer to anxiety and depression. A major challenge we're faced with, however, when searching for new medicine is that of time. There are many parts of the brain that control anxiety and depression, and so many compounds in the plant that may assist in this regard. It would be incredibly expensive and take so much time to test every part of the brain and every compound in the plant. To get around this issue, I use the power of computers. I create exact replicas of the parts of the brain that control anxiety and depression. And I'm able to see which compounds will bind best and even make predictions off of which ones may be toxic before even stepping into the lab. This can give us an understanding of which ones are our top candidates. And this tool is called computational biology. The advantage of this tool is that it can allow us to bring these much needed medications to the front line of the global health pandemic and discover new chemistry as soon as possible.
Thank you so much, Kaelin. Very clear. Thank you for explaining your area of expertise. Over to Sibusiso and then to Natasha for their feedback.
Thank you so much for that. Was a beautiful presentation, and now I know so much about computational biology. It's really wonderful. What do you foresee with initiatives like this one, specifically for yours, with this product going to market? What do you envision, and what do you hope will happen?
All right, I love that question. Currently, Sciletium is South Africa's most researched medicinal plant for the central nervous system. And there is a drug that's on the market called Elevate, and that's high in mesembrine. But another part of my research is looking at, there are other chemicals in the plant, aside from this one chemical called mesembrine. We think that just like the brain has multiple parts that help with anxiety, there may be multiple chemicals that are helping in this regard. So I hope to answer that through my research.
I must say, Kaelin, listening to you talk has eased my anxiety considerably. What a lovely way of modulating your tone. I mean, one very important question when we're dealing with any kind of Indigenous knowledge, there've been a number of examples of Indigenous peoples around the world, including here in South Africa, where that knowledge has kind of been reclaimed and taken away from the people from whom it actually came without any credit or, very importantly, any kind of reward. So I'm wondering how you deal with the people side of your work in terms of perhaps dealing with the communities that have been using Sciletium for centuries before the rest of us arrived here.
Okay, that's a really interesting question. It's been a challenge at first because the main language that the people in the Western Cape and part of the Northern Cape speak is Afrikaans. And some of these areas that we go out to sample, they don't speak English, so we have to communicate in Afrikaans. Getting that across was a challenge at first. And in terms of benefit sharing, there are acts in place that once these products are developed, that these communities still, the benefits are shared back with them. It's not just taking their knowledge and developing products off of it.
Thank you. Oh, and well done for being the only thorn among the roses this year.
Thank you.
I just noticed that. Thank you, Tash. Kaelin, once again, thank you so much. The work you're doing is so important, and honoring the communities it comes from equally so. So thank you for that.
Thanks.
Next up on this line of roses, we have Zakithi Mkhize. Now, Zakithi makes an important point in her bio. She talks about how COVID has stolen the viral limelight. So she notes that while, HIV/AIDS has claimed more lives in a single year than COVID has since the beginning of the pandemic, we've put all our attention on COVID, but HIV is still raging on. She is a PhD student who is passionate about medical research, and her current doctoral study scrutinizes the way that HIV infects people, taking us one step closer to that all-important cure. So Zakithi, over to you.
There is a virus that's been killing people. And no, I'm not talking about coronavirus. This virus infects approximately 37.7 million people worldwide. In sub-Saharan Africa, we're responsible for a staggering 2/3 of this figure. And although this virus has been around for longer than I've been alive, there's still no cure for it. When HIV enters the body, it wants everybody's attention and instructs the healthy cells it infects to make more copies of itself. These copies will then go on and infect other healthy cells, thus spreading infection throughout the body. An HIV-infected person takes a combination of ARVs, which have now been reduced to just 1 pill a day. However, when a person becomes infected, the virus lies somewhat asleep in some of these cells. This means that these cells are infected with the virus, but they're not producing new virus copies, which will then continue in spreading the virus throughout the body. And then thus they cannot be targeted by ARVs. What's worse is that these cells cluster together to form what we call the HIV latent reservoir. The HIV latent reservoir thus serves as a major barrier to finding an HIV cure. We're also not even entirely sure how this reservoir is formed. What we do know is that HIV is made up of 9 genes. And no, I'm not talking about these genes that I had to jump and wiggle to get into this morning. I'm talking about DNA, which make you and I human, but also unique in our own way. HIV uses its own gene called TAT, and TAT plays a very important role in HIV replication. Changes in TAT's DNA are responsible for either increasing the rate of HIV replication or decreasing the rate of HIV replication. When TAT is not present, HIV replication does not happen very efficiently. However, TAT does not perform this very important function alone and has help from another protein called PTEF-B. TAT and PTEF-B work together to enhance the rate of HIV replication. What my study is investigating is how changes in TAT's DNA affect its ability to work with PTEF-B in performing the all-important HIV replication. We also want to know how we can wake up those sleepy cells so that they can begin to replicate again and thus be targeted by ARVs, thus edging us closer to finding a cure for HIV. Thank you.
Thank you so much, Zakithi, for expressing such technical and complex topics in a really accessible way. That was really lovely. Now over to Professor Makunga and Tshiamo for their feedback.
Thank you very much for that. Indeed, and I agree with Verashni, it's not always easy to unpack, molecular biological aspects. So how far are you from, finding mechanisms that might actually ultimately lead to market?
Thank you for that question, Prof. So currently I have completed the first major goal of my PhD, and that was really trying to unpack the mechanism behind how the changes in the genetic variation that we see in TAT affects its ability to work with PTEF-B. So we found one particular mutation in TAT that has really been responsible for a lower viral load that we see in patients of the cohorts that we worked with. So this has really been a clue for us and may possibly lead us to finding clues that will lead us to the disease outcome. So how that patient will do and progress to AIDS if they do.
Thank you so much. It's pretty clear. Thank you.
Thanks.
All right, Zakithi, that was a very informative presentation, and I know nothing about geology, but I think I followed. Just a quick question. You mentioned that you get latent reservoirs that form in the body. A person could ask, if I just continue taking my ARVs, wouldn't this later on make the virus disappear? Why wouldn't it? Because I had a high viral load and I took the ARVs, and so I formed latent cells. If I continued with that treatment, why wouldn't the virus then just disappear?
Thank you for that question. That's a great question. So it will, ARVs do not cause complete virus eradication. So as I explained, so when HIV replicates, so when it makes more copies of itself, those are the cells that the ARV targets. So now in latency, when you have the virus that has infected a cell that's not producing new copies, so the ARVs cannot target that. It's a very kind of hidden, they normally hide in like tissues that we call lymph nodes and things like that. And they hide from the ARVs. However, when a person stops taking treatment, we see what is called a viral rebound. And that rebound usually comes from a latently infected cell that is within the reservoir. So the problem with ARVs is that it's only going to target active replication. So when the cells are making new copies, it doesn't target latent cells.
Okay, great. Thank you very much again.
Thank you.
Zakithi, really well done. I think you answered those questions really well as well. You have a real talent for answering those questions very clearly. So thank you for that.
Thank you so much.
So we're nearing the end of our contestants. Our second last contestant is Shivani Ramburrun. Shivani uses science to bust beauty myths as part of her current master's degree in pharmaceutical microbiology at Wits University. She is challenging some of the beliefs about natural beauty products. Now, from treating acne to smelly feet, natural products like essential oils claim to cure it all, but can we believe it? It's just everywhere. You don't really know what works and what doesn't. So what Shivani is doing is using her science to help us distinguish fact from fiction. Shivani, over to you.
Pimple, pimple, little spot. How I wonder when it will stop. Blackheads, whiteheads, pustules ooze. Like a nightmare I wake up to. Pimple, pimple, little spot, spot I am about to pop. Popping that pimple may seem like the quickest way to get rid of it, but is that really effective? Look at your skin. Can you see your pores? Imagine your pore magnified 400 times. It looks something like this. These are the different layers of the skin, and this is the hair follicle. The oil gland, known as the sebaceous gland, produces a natural moisturizer called sebum. Only a small amount of sebum is necessary to maintain soft and supple skin. In acne, sebum is overproduced. This causes the dead skin cells to become sticky and clog the pore. Bacteria then feed on the extra sebum and overgrow. The overgrowth of bacteria creates pus and causes redness and swelling, or inflammation. This then gives rise to a pustule. Do you then pick and squeeze, and when you finally get that pimple to pop, not only is your bathroom mirror a mess, but the infection is also spread to other pores where more acne can develop. Pimple, pimple, little spot, how I wonder what to plot. Essential oils like tea tree oil are popular to treat acne, but they are also highly volatile and toxic. Carrier oils like coconut oil, on the other hand, are non-volatile and non-toxic. That is why I have combined rosehip carrier oil with essential oils to treat acne. But blending these two oils is not so simple. I study the different types of interactions between rosehip carrier oil and essential oils to identify the ideal anti-acne combinations. Oils can interact to produce an overall negative effect like higher toxicity, have no effect at all, or have a slightly better effect when combined. Rosehip oil combined with certain essential oils stops the growth of bacteria and soothes inflammation much more than either oil on its own. This is known as synergy. Rosehip oil has the same chemistry as sebum. That is why it's able to moisturize the skin, thereby limiting the amount of sebum produced. Rosehip oil also helps to reduce the toxicity of the essential oils so that it does not damage the skin. So next time you have a pimple, little spot, there is a remedy. Worry not. Thank you.
Thank you so much, Shivani. That was highly entertaining and very interesting. And I think it's important to note that we shouldn't just be using essential oils willy-nilly. It's really great to have expertise like yours on the table. So over to your judges, Sibusiso and Natasha, for their feedback and questions.
What a great presentation. Thank you for that. And I'm going to continue resisting pumping a pimple whenever I have one. So I'd just like to know from you and the research that you've done, what would you say is something that people usually get wrong about how they should take care of their skin, particularly acne? What is something that just that's your pet peeve that just you don't like when people talk about it?
Thank you so much for that question. I think that's a really important question. And I think the biggest thing is that people think acne is caused by dirt on the skin. So especially with blackheads, they think that it's actual dirt that clogs the pores, and that's not the case. So with blackheads, it's actually because of a chemical called melatonin in the skin that discolors when exposed to oxygen. So it's not actually dirt. So washing and scrubbing your face and poking at blackheads, that's not going to solve the problem. So people need to understand that it's an actual physiological problem that occurs within the body that needs to be treated.
Well, first of all, I'm off to buy rosehip oil after this, although I suppose splashing it on my face won't work. What I wanted to know, I've heard about carrier versus essential oils before, but I'm not entirely clear, what does it mean to be a carrier oil?
So carrier oils, because they are non-volatile, they don't evaporate as quickly as essential oils. So they're actually called carrier oils because, as the name implies, they're able to carry the essential oil through the skin.
Thank you very much.
Thank you, Shivani. I think your rap skills are also quite entertaining, so thank you for that. We're reaching the end of our program today, and we've come to our last contestant, and that is Nelisiwe Dlamini. She is currently employed as a researcher under the Information and Cybersecurity Center at the Council for Scientific and Industrial Research. Her research looks at how we can make the technologies that make our lives easier safer. With more and more data being shared and stored online, we desperately need computer scientists like Nelly to protect us from scams, misinformation, and hacks. Now, Nelisiwe is committed to keeping your every click or tap safe. Nelisiwe, over to you.
Papers, papers, papers. No, I'm not talking about money. I'm talking about valuable paper-based documents. We've all experienced this, where you walk into a place and the first question they ask you is, do you have supporting documents? Take hiring companies, for example. They usually ask candidates for documents, supporting documents, so that they can verify if these documents are actually valid. It takes time and resources, sometimes leading to skipping the verification process and hiring the candidates. And like this, a candidate who used falsified documents could get lucky. We seriously need a lie detection test for these documents, which is what my research focuses on. Oh no, not the lie detection test, but a solution that will help to detect if a document has been faked. To do this, you need to use methods that make it possible to view all the changes that have been made on this document, which are illegal. So in the solution, we start by creating a document. From this document, all the vital pieces of information are extracted using coordinates, similar to the GPS coordinates that you send to a friend when you want them to locate your home on the map. But these coordinates that I use are used to locate the text on the document. Then I use a hash function, which is a mathematical function. It just takes all the vital pieces of information as input and converts it into a single value that cannot be reversed. It's known as a cryptographic hash. For example, if I give my name to a hash function, it will give me the cryptographic hash as the output that looks like this. This cryptographic hash is stored in a database to be used later on in the verification process to check if there have been any changes on the document. So it will tell us that the document has passed the verification or it has actually failed the verification. Then I went the extra mile and converted each vital piece of information into a checksum. The checksum has a similar representation to the cryptographic hash I just showed you. So this checksum, along with the coordinates, is stored in a barcode, and the barcode has to be printed on the document to be used in the verification process as well. So this barcode in the verification process is used as it's scanned to get the checksums along with the coordinates. Then you can imagine if a person walks into a place and the checksum indicates what has changed in the document. So now a person will be asked, have you changed this document? Thank you.
Thank you so much, Nelisiwe. I think with the increasing cyber attacks we're seeing around the world, the work you do is very important. Over to Nox and to Tshiamo with their feedback and comments.
Thank you very much. That technology is not easy to explain, and I think you did a really great job. I just wanted to know if this kind of technology is already in adoption, or is it totally new, and when can we see it? Because Verashni indicated that cybersecurity is an important aspect, especially nowadays.
Okay, so thank you for the question. So what we have noticed as we've been doing this research is that it is something that exists, but the innovative part about it is that we take the actual words from the document instead of just taking the whole document. And another thing is that this information will be represented differently in this barcode, which will actually allow just about anyone that creates these important documents to be able to see by using this solution if anything has changed. So we're still developing it as well. And it's not currently available here in South Africa. So that's also a good part. Thanks.
Thank you so much.
Okay.
Hi, Nelisiwe. Very great presentation. I just have a quick question. But sometimes when I do photocopies or I scan documents, they naturally get distorted. Now, you explained that the very first step that you take is to use the GPS locations of text and indices within the document. So what would happen if the document that I'm scanning or photocopying gets distorted? Would it then appear as a fake?
If the document is distorted?
Yes.
Okay.
When I'm photocopying it or so.
Okay, thank you for the question. So the coordinates that we use are actually just the XY coordinates of where the text is exactly on the document. And one of the things that we started with was we want to start by working with a copy that is not distorted first. So, and then after that, the next phase will be to look into the distorted documents, because one of the things that you realize is that like you're saying, that as you print, etc., the documents kind of gets distorted. So that's the next thing that we will be looking at. We haven't started looking at it right now. Yeah. But the whole idea of the solution as well is to make sure that even something that is distorted will be able to be corrected, and then it will give the right results. Thank you.
Thanks, Nelly.
Thank you so much, Nelisiwe. I'm sure you had the most nerves of everyone. You've been hanging around waiting to do your talk, and you really hit it out the ballpark. Well done for keeping your energy up right till the end. To all our contestants, you guys did so well. We're so impressed with all of you. Well done for making it this far. Well, the judges are back from their deliberations, and before we hear what their decision was and who the winner is of today's competition, let's hear a little bit more about what they have to say about today's proceedings.
FameLab South Africa is probably one of my favorite days of the year because I get to spend a few hours hanging out with brilliant young scientists who are doing incredible thinking and communicating it in a way that is easy for ordinary folks like me to understand. And this year was an amazing set of contestants. I can assure you the judges had quite a lot of fun and quite a lot of robust discussion in our session. They were really struck by the care that people had put into crafting their presentations, and also the incredible excitement that people have about the science that they're doing. I think I said at the very beginning that quite a lot of scientific writing and scientific journalism can be stripped of the wonder that there is in science. And watching all of you clearly really excited about what you're doing and about the places that your science can take you and that you can take your science was a real honor and a privilege. So thank you so much to all of you. If you didn't finish among the winners, then please don't consider this the end of your science communication journey. It's just the beginning. And I'm looking forward to seeing much more from all of you in future.
What a wonderful set of scientists, young scientists excited about their work. I work with researchers in my day job, and I'm always so happy and excited whenever I'm able to speak to one who's excited about the work that they do, who's enthusiastic about their own research and love talking about their science. So today it was an incredible cohort of people who are excited about their work in that way, and just highlighting the different aspects of science and also highlighting things like indigenous science, indigenous research, or indigenous knowledge systems, and other things like that. So I'm very excited for the work that they've started showing to the world today, and hopefully for the winners and everyone else, I consider everyone winners for being here today. For everyone, I hope you continue with the enthusiasm and the excitement that you have for your work to present it to the rest of the world. So congratulations to everyone.
Today's session felt like I was in a time tablet. It felt like I was traveling through time, because all the speakers started from prehistoric times to how people who lived on this earth before us lived and benefited from plants, to how today we are living and how we are affecting the climate and the future, to groundbreaking technology that will be used in the future. All the contestants were great, and your passion came through very strongly. All of you contestants are stars, and with you at the forefront of science communication, science and its communication will continue to shine very bright.
What a wonderful time spent listening to a range of diverse sciences that are being conducted here in South Africa, and the deliveries were awe-inspiring. And as a communicating scientist, I am very excited and inspired by this cohort of finalists that was part of FameLab 2021. We have had a very difficult time as judges in actually making a decision, because everyone that participated was truly amazing. And this for me says that the future of science communication and science in South Africa is being held by excellent hands. It has been a very exciting morning, and I am wishing the winner all the best for the next tier of this particular competition, and congratulating the runner-ups. But also I'd like to emphasize that every single participant did an excellent job, and our job was very, very difficult, and they themselves are definitely winners. We have so much talent, and that talent is going to carry you, FameLab finalists, definitely into the future and into your future endeavors in labs, in the field, and in communicating and engaging with science. Thank you.
Thank you to all our contestants for your hard work, your preparation, and your amazing talks. We are going now to a special vote of thanks from Susanna Galvan, who is the British Council South Africa's Country Director, as we wrap up proceedings today.
Hello, everyone. It is a great pleasure for me to make this video and to share a vote of thanks at the 2021 FameLab South Africa National Final. My name is Susanna Galvan, and I am the Country Director at the British Council in South Africa. FameLab has been running now in South Africa for 8 years, since 2013, and has been implemented through a partnership between the British Council, the South African Agency for Science and Technology Advancement, SASTA, and Jibe Media Africa. As the British Council globally concludes its partnership with the Cheltenham Festivals this year, we are very, very grateful, and particularly grateful for the important work that this local partnership in South Africa has delivered, reaching out to hundreds and hundreds of researchers, but also highlighting the importance and the beauty of science, and how important it is to have effective science communication and creative science communication. We are actually very encouraged that even though the partnership with Cheltenham Festivals is coming to an end, we are very happy by the fact that Jive Media Africa and SASTA will continue to deliver FameLab in South Africa, FameLab South. FameLab South Africa, I think it's important to know that it encourages diversity and has more emphasis on capacity building than it has on the actual competition. So this program is a means of identifying and nurturing more diverse voices in the science community, to encourage, of course, science communication and innovative science communication. And it will continue to be a valuable initiative. The focus is less about finding the best speaker and more about identifying those with the potential to enrich society's understanding of various complex issues through science. Finally, I would like to really thank all the individuals and institutions who have been involved in carrying us all the way through to the 2021 FameLab South Africa National Final. Of course, to all our institutional partners, the universities and the research organizations that have supported FameLab, hosting 10 regional trainings and heats. thank you to the judges that have participated in the semi-final and in the final, having to make very tough decisions to select the winners. Again, thank you for offering not just your time, but your very, very valuable expertise with us. Of course, to all the participants, it's obvious that there would be no FameLab at all without you. So thank you so much for participating and sharing your valuable work and your creativity and passion with all of us. We, of course, are required to select just one winner who will represent South Africa at the international finals. But of course, all participants are champions. You're all champions in your own right. I really would like to congratulate and thank again all the FameLab participants for being part of this truly transformative program this year. And of course, to all the audience, a big thank you for joining this national final and kind of taking in and soaking in all the inspiring talks that the researchers have shared. I hope you have enjoyed it. Thank you so much, and good luck on the next stage of the international finals of the FameLab competition. Thank you so much to everyone. Thank you.
And now the moment you've all been waiting for, the winner of FameLab South Africa 2021. The second runner-up is Tasvi Daya. The first runner-up is Caitlyn Rabe. And our winner today is Letago Kgomoeswana. Congratulations to all of you.